Hello everyone, welcome to the chemistry class. So today we would move on to the next topic 1.5, a closer look at gases. Particularly what we are going to talk about is pressure on gases and pressure of the gases, pressure of the gas particles. All right, so let's talk about that. Let me Okay, so what is gas pressure? Let's talk about that. All gases are made up of particles. We have already established that. Those particles are usually molecules, right? Another thing that we established that those molecules are always moving, are constantly moving. And they are moving rapidly. So if they are moving, then these molecules would collide with one another. They collide or they strike each other, and also the walls of container in which you have kept them. Okay, so not only these molecules collide with each other, they collide with anything that come in their way, even with the walls of the container. Right? Let me give you an example. If you blow up a balloon, right? A balloon, what happens? It is filled with air molecules. It's filled with the air particles. It is filled with air particles. I think we talked about it a little bit, and these are molecules of, like, in the air they are like nitrogen molecules, oxygen molecules, O2, and probably carbon dioxide molecules and a bunch of other molecules, right? So now the balloon is filled with these molecules, right? And these molecules will collide, or they would strike the balloon. Okay, they constantly collide with the walls of balloon. All right, and that is what keep the balloon inflated, right? When these tiny particles hit the walls of the container, they exert pressure. Okay, when they collide, their collision, right? These molecules collide, and when they collide, they exert pressure. Right? Now, if we talk about it, what is pressure? Pressure is basically force applied by something, in this case, force applied by the molecules, collision of molecules, per unit area. On a specific area, how much force is being applied. That is pressure. Right? In this case, molecules collide with the walls of the balloon or any container in which you have kept it, and when they collide, they apply a certain force at the unit area, at that particular area. We call it the gas pressure. Okay, that is the pressure exerted by the gas molecules, right? So keep that in mind. The next point that we are going to discuss is when you change the pressure. when you change the temperature, changing temperature. Changing temperature. So what's the effect of changing the temperature? Right? Now, you should know that let's take an example here. Okay? Imagine a cylinder. Right? And that cylinder is it is fitted with a movable piston. With a movable piston at the top. Right? And let me get you this image here. It would be much better to explain with that. Right? Let's see that. So yeah, this is the image here. Now imagine this is the container we are talking about. Okay, this is the container we are talking about. Okay, what happens in the number one? This is the movable piston at the top. The piston can move up and down freely depending upon how much pressure you are applying. Okay, so now at this point it is kind of like at a stable state, right? So these are the gas molecules inside, and they are colliding with each other, and they are also colliding with the walls of the container here, and at the same time they are colliding with the this piston, right? And they are exerting pressure towards the upper side. Okay, so that is keeping this piston up here. If they are not applying pressure, these molecules are not applying pressure, this piston might fall. It might go all the way to the bottom of the container. Okay, the only thing keeping this piston up here is the pressure applied by the collision of the molecules. Okay, so look at this. The pressure is the same inside as the outside of it. So at this point, the pressure applied by the piston on the gas and the pressure applied by the molecules on the piston is almost equal. That's why it is stabilized here. You can call it at equilibrium. Okay, now what happens if you start heating this gas? If you start heating this cylinder, right, what happens is that when you heat it, the energy of the molecule increases. So they move faster, they collide faster. When they collide faster and with more force, they have more energy, right? So what happens is that this piston moves further up due to the high pressure, and that pressure came from the molecules due to the heating. Okay, when you heated it, right? So the piston moves up. Why? And the volume of this gas have been increased. The amount of gas is same. The amount of gas here and here is same. The only thing that have been changed is the energy of the gas molecules, which increased due to you heating that gas, you heating that cylinder. Okay, so the pressure applied on the cylinder or by the piston did not change, but the pressure applied by the gas on the piston upward, this pressure upward, has been increased. So it pushed the piston up, right? So volume has increased. This much volume has increased like this, right? So I hope you got that. Now, in the next, what if you cool it down? So molecules movement decreased. Now they are colliding less because they have less energy, right? So the pressure applied by the piston on the gas is the same, but the pressure applied by the gas molecules on the piston, the pressure which was upward, has been decreased. So the pressure applied from outside is same, but the pressure applied by the gas on the piston has been decreased. Why? because we cooled it down, the energy of the gas molecule has been decreased. Okay, so what's the conclusion here, right? What's the conclusion here? Number one, what happens when you heat up a gas? What happens when you heat up the gas, right? Number one, when you heat up the gas, the molecules or the particles would move faster, right? And they have more energy coming from the heat, from the temperature. Okay, when they move faster, they apply more these molecules, right? These molecules, they collide more often, plus they apply more force. Okay, and when they apply more force with whatever they are colliding with, okay, so their volume would increase if it's possible. Okay, so the rule here is when you heat their volume increase. So the rule here is when you heat up the gas, when you heat any gas, its volume increases. Okay, kind of like you can say the volume V is directly proportional to the temperature. So this was a rule called Charles' law. Maybe we would talk about that in the future, not right now. So this is our rule. You heat up the gas, its volume would increase, and the pressure of the gas would also increase due to increased collision, right? The next point that you need to keep in mind is what happens when you cool down the gas. The opposite would happen, right? The opposite would happen. The particles or the molecules slow down, plus they would have less energy, so they would collide less. If they collide less, so they would apply less pressure. So if they would apply less pressure, right, so their volume would decrease. The gas volume decreases. This is our rule, right? When you cool down the gas, the volume decreases. Okay, cool down the gas, volume decreases. Okay, so this is what I mean when I said the volume is directly proportional to the temperature. If you increase temperature, volume increases. If you decrease temperature, the volume would decrease. All right, I hope you got the idea. The next point that we are going to talk about is what happens when you change the pressure, right? So let's talk about that. Changing pressure. But keeping the temperature constant. Constant temperature, but pressure is being changed, right? So what happens if we do that? Okay, remember when we are talking about pressure, the pressure on the gas. Okay, so let me show you the diagram here. Okay, I should have it here, hopefully. Okay, so this is Yeah, look at this. This is the similar experiment. What's going on here is that this is the piston and it's stabilized here. The pressure from outside and the pressure from inside is equal. But if you increase the pressure on the gas, okay, the pressure is increased, right? So the pressure is increased, right? But pressure from inside is the same. So what happens is that gas molecules have large spaces between them. They would come closer to each other. They are still moving with the same energy because temperature is constant, so energy is constant, okay? But they are moving, they are colliding, but because the external pressure is very high, they have been squeezed together, okay? They have been jammed together, so their volume decreases. But if we decrease the external external pressure, and the internal pressure remains same, then the piston move up, all right, and the volume would increase. Piston moves up. So from this we can get an idea, right, that if you increase the external pressure, if external pressure on the gas in a cylinder is increased, it decreases gas volume. And on the other side, if you say if external pressure is decreased, the opposite effect would be observed. The volume increases. In a way, you can say the volume of the gas is kind of like inversely proportional to the pressure. If you increase pressure, the volume goes down, the volume decreases, okay? So that's what you need to keep in mind, right? The next point we need to discuss here is the diffusion, about the diffusion, the rate of diffusion. The rate of diffusion. If you remember, we talked about diffusion. What is diffusion? It's the intermixing of the gases or the movement of the gas particles and liquid particles from high concentration to low concentration, or the point where they are more to the point where they are less, right? So you can call it the diffusion. But do all the gases diffuse at the same speed, at the same rate? I don't think so. Let's see that. Okay, let's talk about that. So remember, the gases diffuse, liquids also diffuse much slower, but they do diffuse, okay? The gases diffuse because their particles are constantly moving. The molecules or the particles are randomly moving. So if they are randomly moving and they are colliding not only with each other, but also with the walls of the container or whatever comes in their way, so they keep moving from the point where they are more high concentration to the point where they are less low concentration, okay? But let's talk about their speed. What's the big rule here that you need to keep in mind? The big rule here is that the rate of diffusion or the speed of diffusion, okay, it depends on the mass of molecules, mass, or you can say the MR value, the molar mass of molecules. So it's a simple rule, okay? If the molecule is larger, bulkier, it would move slowly. If the molecule is very small, very tiny, it would move faster. Okay? Let's draw a diagram to support this idea. Okay? Imagine you have a glass tube here. Okay, let's say this is a glass tube here. Transparent glass tube. This is glass tube. Glass tube. Right? And what did we do is that we added a cotton plug here soaked in, let's say, ammonia solution. Okay? So cotton, wool soaked in ammonia, NH3, right? Ammonia. Right? And on the other side, we have this cotton plug, similar cotton plug, but this one is soaked in, instead of ammonia, this one is soaked in HCl, hydrochloric acid. Okay? Hydrochloric acid. Right? And they easily react. Now you can wait. Let's increase it a little. Okay, so what happens is that now you wait. After a couple of minutes, what happens is that you would see some fumes forming here. Okay, you will see some white fume forming at this. This is too close. At this point. Okay, these are the white smoke or white fumes. White smoke of ammonium chloride being formed by the reaction of ammonia and HCl. So what happened is that the ammonia, which was soaked in this cotton wool, it vaporized and it started moving. It was too much here, so it started in the form of gas. It started moving here towards, low concentration, high concentration, low concentration. So it started moving from high to low concentration. Same thing was done by the HCl, okay, from high to low concentration. But they reacted here. It means the distance traveled by the HCl, let's say this is the distance traveled by the HCl, right? And this is the distance traveled by the ammonia. So ammonia traveled much faster and further than the HCl. This shows that the rate of diffusion of ammonia was larger or higher than the rate of diffusion of HCl. HCl moved slower, ammonia moved faster. Okay? So we can say this is our observation. What's the observation here? Okay, so what's the observation? The smoke or the fumes smoke produced was closer to the HCl cotton, right? Why? The conclusion that we can make from this is that HCl diffuse slower or with lower speed than ammonia. Okay, this is our conclusion. Why? Ammonia diffuse faster, right? Faster. Why? Because number one, the size of ammonia molecule is smaller and its mass is lower, okay, than the HCl. All right. So the size of ammonia is smaller and mass is less than HCl. So mass being less for the ammonia allowed it to move faster as compared to the HCl. This is the idea about the rate of diffusion. Okay. So from this whole experiment, we can say that the gases whose molecules are smaller or lighter, or you can say they have less mass, they would diffuse faster than the gases with heavier molecules, right? So that's the end of this whole topic. The summary ideas that we talked about in this whole topic is number one, if you increase the temperature of the gas, the energy of the molecule increases and their volume increases. But if you increase the pressure on the gas, their volume would decrease. The temperature and volume of the gas are directly proportional, whereas the volume and the pressure are inversely proportional. The final idea, the last idea that we talked about, is that the gases with lighter molecules diffuse or move faster than the gases with heavier molecules. Right? Now, we have the exercise questions of, of this topic. Let's talk about that as well. Yeah. So you can see that. Okay. This is it. So I would keep it short, to the point. Let's talk about question number 1. What causes the pressure in a gas? I think I don't need to talk about this. I have already talked about it up there. You can go and check it out. The gas molecules are constantly moving. They collide with each other and with the walls of container. And when they collide, they apply force with whatever they collide. And that is the pressure. Okay. Let's talk about question number 1. If you want to give like a very precise answer, all right? So the collision, the consistent collision of particles, gas particles, right? That's what causes the pressure. Number 2, what happens to the volume of the gas as you heat the gas? When you heat up the gas, the volume increases. Why? We just talked about it. Because the energy increases, the collision increases, so volume increases. And as you cool down, the volume decreases. Volume decreases because the energy decreases, the collision decreases. Number 3, part A. So how does the volume of the gas change if the pressure is increased? If the pressure on the gas increases, the volume decrease. Okay? And if you decrease the pressure on the gas, the volume would increase easily. Obviously at a constant temperature. Okay? Number 4. In the diagram labeled 1, the piston can move up and down freely using the idea of the particle. Explain why. I have already explained it up there, so you can check it out. The volume of the gas increases as the gas is heated. So particles will move faster and they collide more. So it increases, if the pressure is kept constant on the gas, and you heat up the gas, the molecules' energy increases, they move faster, they collide more, and that would increase the volume. Okay. If you cool down, then the energy decreases, molecules move less, so that would decrease the volume. Okay, let's go to the question number 5. Look at the diagram label 2. You can force the gas into a smaller volume by pushing the piston down using the ideal particle. Explain why its pressure rises. Okay, so question number 5, let's talk about that. So the particles are in smaller spaces. Okay, the particles are now in smaller space. Okay, and if they are in smaller space, so they would strike or they would collide the walls of container more. So their pressure would, the pressure of the gas would also increase. If you increase the pressure on the gas, the volume decreases. Now they have to fit in less space, so their own pressure also increases. Okay, let's let's move on to the number 6. In the diffusion experiment above, there is an air in the tube. Explain how the ammonia particles move from A to B. Explain why the hydrogen chloride particles don't move as fast as the ammonia particles. I think we talked about this. Let's see, number 6A. Okay, so the air particles are moving randomly. Okay, the air particles move randomly. They are also molecules, so they are moving randomly, and they bounce off other particles in all directions. They would also strike the wool, and they would also strike the ammonia particles coming out of the wool. All right, so that's how the ammonia particles would diffuse. Okay, then B, the why HCl particles move slower? Because HCl molecules are heavier than ammonia molecules. That's why they move slower. It's a general rule that if let's say two boys of the same age are running a race, so probably if one of the boys is much healthier, much bulkier, that boy would move slower. Okay, if the other one is very smart, very skinny, so probably that skinny boy would move faster. Okay, so that's how it works. Then the next question, last question. Of all the gases, hydrogen diffuses faster at any given temperature. What can you deduce from this? Okay, if heavier molecules move slower and lighter molecules move faster, and hydrogen move fastest, then we can deduce from that the hydrogen particles are the lightest particles. Okay, so probably hydrogen, not probably, actually hydrogen molecules are the smallest. Okay, or hydrogen, we can deduce that hydrogen molecules have lowest mass. Right, they are the lightest, smallest. That's why they move fastest, or they diffuse fastest. So I hope this helped. If you have any questions, let me know. We can discuss that. Take care.